Sets. What are sets? Sets are written like this. Anything enclosed in curly brackets, whatever is inside the sets are members or elements of a set. We have an empty set also. Empty set is written like this or it is written like this. This symbol is called phi, P-H-I, phi. If you write a null set, try to write a set like this. This is not a null set because phi is the member of this set. There are different kinds of sets. What kinds of sets we have? First set is an overlapping set. An example of overlapping sets is, for example, A is equals to 1, 2, 3 and B is equals to 1, 7, 9. When you have some elements common between the two sets, these are overlapping sets. And how do we draw this Venn diagram? Venn diagram is a diagrammatical representation of a set. You draw Venn diagram of these sets like this. You name the sets outside A, B. In the middle, you will write the common member 1. Remaining members outside. This is an overlapping set. Another set is a disjoint set. What is a disjoint set? Disjoint, as the name suggests, not joint. These are separate sets. These sets do not have anything common at all. For example, these two sets. How do you draw these two sets? You draw two circles separately and you fill in the elements inside. There is nothing common, that is why everything is separate or the circles are separate. The circle represents a set. Then we have a subset. What is a subset? Sub means small. Okay, so subset is a small set of a bigger set. For example, 1, 2, 3 and B is equals to 1, 3. Now, what is the difference between a subset and a superset? If you see the smaller set, all the members of smaller set are part of the bigger set. There is no such thing in the smaller set which is not common, and that is not the case with an overlapping set. That is why these are different kinds of sets and they are subsets. How do we draw subsets? Do we draw subset like this? No. We draw subset in a different way. Bigger set and smaller set inside the bigger set, in the tummy of the bigger set. The bigger set has eaten the smaller set, that's why all the members are inside, and the remaining uncommon member of the bigger set will be part of the bigger circle. This is how you draw a subset. Now, smaller set B is a subset of A and bigger set A is a superset of B. Bigger set is superset, smaller set is subset. Then we have operations that are done on the function. What are the operations? Two kinds of operations, union and intersection. Union, as the name suggests, is all the members, or union means add or everything together. For example, let's take this question here. A is equals to 1, 2, 3 and B is equals to 1, 7, 9. So A union B is equals to 1, 2, 3, 7, 9. We don't repeat the common members and we don't write them twice. We write them only once. Now for again the same question, the other one is intersection. Intersection means common. Intersection of disjoint sets is a null set because there is nothing common in between the two. Intersection is denoted by an inverted U. A intersection B is 1 only in this case, right? 1 only. Intersection of subsets is, for example, if we do A intersection B, for this one you will have the smaller set complete, and if you do A union B of subsets and supersets, then you will get the bigger set, as we do not repeat the common members. There is another thing which is called a universal set, but I'll come to it later on. There is a formula to calculate number of elements of a set. Number of elements is denoted by a small n, and the formula is number of elements of A union B is equals to number of elements of A plus number of elements of B minus number of elements of A intersection B. A intersection B is subtracted for a reason. Let's have a look at the reason first. For example, in case of this overlapping set, if you take A separately, which is 3 members, and B separately, which is also 3 members, if you add both of them, it becomes 6 members, but in total you will have 5 members, not 6. Why? How 5 members? Let's have a look. 1, 2, 3, 4, 5. You will have a total of 5 members. Let's test the formula using this question. Number of elements of A union B is equals to number of elements of A, which are 3, plus number of elements of B, which are 3, minus number of elements of A intersection B, which is 1. Answer is 5. And we know that the answer is 5. A union B, 1, 2, 3, 4, 5. 5 numbers. Okay? Alright. Now, let's come to how you shade a Venn diagram. For example, this set is given to you. This set is given to you and they ask you to shade A intersection B. You will shade this middle portion, A intersection B. Whatever is asked for, that is the final shaded region. Then if they ask you to shade A union B, you will shade this entire part. Shading means you just shade it the way we shade anything in pictures or shade anything on sketches with a light pencil. Or you can just shade it like this. And that is also okay, but make sure that the numbers are clearly visible. Alright, now coming to universal sets. What are universal set? Universal set is one big set and all the other sets are subsets of this universal set. For example, let's take an example of a universal set. Universal set is denoted by an E. Universal set is numbers, first 10 whole numbers from 1 till 10. A is equals to 1, 3, 5, 7, 9 and B is equals to 3, 6, 9. These are 3 sets. One is a universal set, 2 A and B are 2 other sets. Let's draw a Venn diagram. Universal set is always drawn as a rectangle. And other sets, as we can see, they are overlapping sets. So we will draw 2 circles inside this rectangle. We will name them and we will start filling the Venn diagram. Always start by filling the common part. So let's have a look. What is common between A and B? 3 and 9. So we will write 3 and 9 here. A we have 1, 5, 7. B we have 6 only. And what do we fill in the rectangle? We fill the remaining members from this set. We have 1, we don't have 2, we don't have 4, we don't have 8 and we don't have 10. This is a complete Venn diagram. Now on this Venn diagram we will perform a new kind of operation which is called complement. And it's denoted by a dash. For example, a complement is written like a dash. This is the dash. It's like apostrophe or just a small line like this. So this is a dash or a complement. A complement means universal set minus a, and when you shade it, it is everything except for a, means whatever portion is of a you will leave that out and you will shade everything except for a, which means it will be shaded like this, and you will have to let go of the middle portion, the common one as well. This is a complement. Similarly, if we look for B complement, then we will shade everything except for B. For example, B complement will be shaded like this, and you will have to leave the middle portion in this one as well, because B has part of this as well. So this will not be shaded. This is B complement. And if you have A union B complement, something written like this, then you solve the bracket first. Means you will first find out A union B and then find the complement. Let's do an example. A union B whole complement means first you find out A union B. A union B is equals to 1, 3, 5, 6, 7, 9. And now when you find out A union B complement means everything other than A union B from the universal set, which will be 2, 4, 8 and 10. If you look at this Venn diagram, everything other than A union B will be shaded, means the box. Everything except for these two circles, and we can see that the numbers that we have outside are 2, 4, 8 and 10. So our answer is correct. But on the other hand, if you have a question that says A complement intersection B, there is no bracket. So first you will find out the complement. A complement is universal set minus A. The answer will be 2, 4, 6, 8, 10. Now when you intersect it with B, intersection B is 3, 6, 9. So we get the value only 6. A intersection B complement, the value is 6. If you are asked to shade this thing on the Venn diagram, you will shade only this part, right? So this is how you are going to shade the Venn diagrams. But for this one, if we want to know the number of elements where there is something written in the rectangle also, which means numbers that are not part of any set, how do we do that? Number of elements of A union B, or you can write total number in a universal set is equals to number of elements of A plus number of elements of B minus number of elements of A intersection B minus everything which is left over. Okay, so let's suppose that we don't know the number of elements of A intersection B. Let's suppose, okay, and we will find it out. It has to come out as 2. Number of elements of a universal set, we can see it's 10. 10 is equals to number of elements of A are 5. Number of elements of B are 3. Let's say we don't know this. And number of leftovers are 1, 2, 3, 4. So in place of leftovers, we are going to write 4. Let's bring this thing on the other side because this is minus, and 10 will go on this side. So 5 plus 3, this will not be minus, this will be plus. Okay, 5 plus 3 plus 4 minus 10. So this is 12 minus 10 is equals to 2. Why did I add the leftovers? Because this is part of the universal set. That's why I have added the leftovers. Answer is 2. It means the formula is correct. So this is all about sets, but let's have a look at a question which has 3 sets in it. This is one of the questions that confuses students. Let's have a look. You draw 3 sets like this when 3 sets are overlapping. You may get 3 sets in which 2 of them are overlapping and 1 is different, right? You may get 3 sets which are like this. 2 of them are subsets and supersets and 2 of them are overlapping. You can get such questions as well. But mostly the questions come from the sets that are overlapping. 3 sets that are all of them are overlapping. So A, you start filling the Venn diagram with this green highlighted portion first, because this is the part of the Venn diagram where the members that are common in all 3 of them, they go. This is B intersection C, A intersection C. Elements that are not common in any of the sets but are part of only C, elements part of only B, and elements part of only A. This is how you fill the Venn diagram. Let's have a look at the question. For example, if you have this kind of a question, let's say this one. This kind of a question, how do we fill this up? Elements of, let's say, see what is common in all 3 of them. First, let's have a look at that. We have 7, and then we have, that is it. We have only 7 which is common in all of them. Now, what is common in A and B? In A and B, we have 29. That's it. So A and B, we have 29. In B and C, we have 15. That's it. BC, we have 15. A and C, we don't have anything common. Now, what is left in A? 1 and 5. What is left in B? 11. That's it. And what is left in C? We have 17, 19, 25 and 27. Now the question is, does the order matter? The order in which we write the numbers? No, it does not matter. It's just a placement. Like for example, you can see I have written 27 in the beginning because I was short of space, and that is perfectly okay. Now does anything go outside in the rectangle? Yes, because the universal set is odd numbers less than 30. We have 1, we don't have 3 in any of the sets, so it goes outside. We don't have 9, then we don't have 13, we don't have 21, we don't have 23. All the other numbers are there, right? It's the odd numbers less than 30. This is how you will complete the Venn diagram. This question is of probability, so I am leaving it for now. But once we are done with probability, you can come back to this question and attempt it. Here, you just had numbers, but there will be another question where you will be required to draw a Venn diagram where a question is given like this. Let's have a look at it. Sami asked 50 people which drinks they liked from tea, coffee and milk, and all 50 people drink at least one drink, means that you will have, or the 3 sets are overlapping. There is no such person who does not drink any drink. So this is like all the members, they will add up to 50 people inside it and there is no universal set. Okay, all right. Now let's say this is tea, coffee and milk. Okay, 19 people like all three drinks, 19 goes here. 16 people like tea and coffee but not milk, means here. 16 people like tea and coffee but not milk. 21 people like coffee and milk, means this plus this, coffee and milk, because this is also part of coffee and milk. So we will write 19 plus 2 is equals to 21. 24 people like tea and milk, means this and this. So this is going to be 5. 40 people like coffee. 40 people like coffee means this plus this plus this. So let's see. 19 plus 2 is 21. 21 plus 16 is 37. 37 plus 3 is 40. So here we will write 3. One person likes milk only. Now we have to find this out. How do we find this out? We know that the total number of people is 50. So 19 plus 1 is 20. 20 plus 10 is 30. 30 plus 16 is 46. And 46 plus 4 is 50. So this is your Venn diagram. Again, this is the probability question. You have to leave it for the time being. But I hope you have understood how you fill in the Venn diagram. Similarly, let's attempt this question as well. 60 people, which sport they like from all of this. So these are again overlapping sets. 3 overlapping sets. Let's name them. This is rugby, football and cricket. 8 people like all 3 sports. 17 people like rugby and football. This is how we are going to fill this Venn diagram. The only thing that I want to explain here is this part. 17 people like rugby and football, and they haven't written rugby and football but not cricket. Right? Rugby and football means these two need to add up to 17. Right? They haven't said not cricket. These two need to add up to 17. How many people liked neither rugby or football or cricket? They have to add up to 60 people. If there are no 60 people, then obviously we have to draw a box outside as well. But first let's see whether it's adding up to 60 or not. 11 plus 9 is 20. 20 plus 16 is 36. 36 plus 6 is 42. 42 plus 5 is 47. How many people liked neither sport? How many people? 13 people did not like any sport. So we are going to draw a box and write 13 in that box. This is how you draw this Venn diagram. So this is all about sets.